Hey guys, Mr. Burns here with your video for lesson 7.2, comparing rational numbers. By the end of this video, I want you guys to be able to compare and order and compare rational numbers. A number that can be written as a fraction of two integers is called a rational number. Integers, fractions, and some decimal numbers are types of rational numbers. The Venn diagram off to the right shows that all whole numbers are integers and that all integers are rational numbers. The set of rational numbers also includes fractions and some decimals that are the result of division of two integers. Just as whole numbers have opposites, each rational number has an opposite. For example, negative 3 2/5 and positive 3 2/5 are opposite because they are both the same distance from zero. Both of these numbers have the same absolute value. In example number 1, it says find the value of each number, of each expression, and graph each rational number on the number line. So you've got A, B, C, and D. Now for part A, it says the absolute value of a number is its opposite from zero. So the opposite value of negative 3.5 is 3.5. For B, we've got the negative, or the opposite, so this negative sign in front can be read as the opposite of negative 1/2. So for part B, the opposite of negative 1/2 is 1/2. For part C, the absolute value of a number is its opposite from zero, so the absolute value of 1.5 is 1.5. So then on part D, it says the opposite, so the negative sign on the outside. The way you read this is, the opposite of the absolute value of a number, in this case 3, is negative. So you take the absolute value of negative 3 first, which is, so what is negative 3's distance from 0? That would be 3. And then you make it its opposite by attaching the negative sign to it. So the opposite of the absolute value of negative 3 is negative 3. Alright, let's move on to the next page. So on this page, it says a number line is a useful tool when ordering and comparing fractions and decimals. So example number 2 says use a number line to compare negative 7.4 and negative 7.38. So the solution says decimals on a number line get larger as they move from left to right. The reason is this is getting closer to 0. Okay, so the closer a number gets to 0, the larger it is, okay, in value. So in this case, you got negative 7.4, okay, and negative 7.38, and they say put the decimals on a number line. Well, one of the first things that I like to do is make sure that my numbers have the same amount of digits, and here's what I'm talking about. So originally, our number is negative 7.4, and the other number is negative 7.38. So the first number, negative 7.4, only has 2 digits. So I want to add a third digit. And when I add digits, I always add it to the end. In this case, the only digit that I can add without changing the original value is 0. But now it makes it a little bit easier for me to compare. So with negative numbers, the larger the number itself, forget about the sign for a second, but the larger the number it is, okay, the farther left of 0 it is. So you got negative, so you've got 7.40 and 7.38. Which number is bigger? That number is bigger, so when you're talking negative numbers, that number is farthest to the left. So therefore, it is smaller. All right? So negative 7.38 is a larger number. So when you rewrite this, negative 7.38 is greater than negative 7.4 because it is closer to 0. Common denominators can be helpful when comparing fractions. Once a common denominator is found, the numerators can be compared. So you find a common denominator first, okay, and then you compare the numerators. So for example number 3, you've got list the following fractions from least to greatest. So you got negative 1/2, negative 1/6, and negative 1/3. So it says the denominators are 2, 3, and 6. List the multiples to find the least common multiple, and then use the least common multiple as a common denominator and create equivalent fractions, which is what they do here. after you have the same denominator, all you have to do is compare the numerators. So the numerators are negative 3, negative 1, and negative 2. So out of those three numerators, which one is the farthest to the left of 0? That would be negative 3. So that fraction would be negative 3/6. It would be smallest, okay, out of all the three. The next one after that is negative 2/6. And the last one, okay, is negative 1/2. And it is, 1/6. Yeah, 1/6. My bad. Okay, and it's the largest because it is the closest to 0. All right, so there you go. Hopefully that makes some sense to you. Once you have a common denominator, okay, and you convert it to equivalent fractions, all you have to do is compare the fractions. Okay, let's move on to the next page. All right, so here we are with lesson 7.2T, comparing rational numbers. So in part 1, it says graph negative 2 and negative 1/2 on the number line. So here we have our number line. So if I was to graph negative 2, it would be right here. And if I say negative 1/2, so if I start at 0, and if you notice, so from 0 to negative 1, there's a line in between. Those are the halfway marks. Okay, the halfway marks. 0, 1/2, 1, 1, 1.5, 2, 2.5, and so on. So if I was to mark negative 1/2, okay, negative 1/2 would be right here. So out of those two numbers, which one, okay, like it says, which one is bigger or farther to the right on the number line? Or, like I like to say, which one of these two numbers is closest to 0? That would be negative 1/2. So complete the statement using less than or greater than. So negative 2 is actually less than negative 1/2 because negative 2 is farther away from 0 than negative 1/2. For number 2, the graph shows a number line here, and if you'll notice, it starts at 0, goes all the way to 1, and then there's these hash marks in between. So how many hash marks are there? So we got 1, 2, 3, 4, 5 hash marks. So each one of these hash marks is worth 1/5. So I've got 1/5, 2/5, 3/5, 4/5, and now number 1 is 5/5, or 1. Going to the left, it's the same thing. So from 0 to negative 1, you've got 5 hash marks. 1, 2, 3, 4, 5. Okay, so each one of those little hash marks is worth 1/5. So negative 1/5, negative 2/5, okay, negative 3/5, negative 4/5, and negative 5/5, or negative 1, right? So let's go ahead and graph both of these rational numbers on this number line. Choose a different color here. So negative 3/5 is right here, and then negative 4/5 is right here. So out of these two numbers, negative 4/5 and negative 3/5, which one is bigger? So which one is farther to the right on the number line? That would be negative 3/5. So negative 3/5 would be larger than negative 4/5. All right. So here we go with numbers 3 through 7. 3 through 5. So it says complete the statement using greater than or, less than or greater than. And what I'm going to do is I'm going to zoom in on these problems so that way I can draw a number line and show you guys. And it'll come in really handy here when we talk about number 4 and number 5 as I explain this to you guys. So on number 3, on number 3, we've got negative 3, and they want us to compare that to negative 2. So what we can do is we can draw ourselves a number line, put 0 in the middle, and then we're going to go 1, 2, 3, 4, 5 to the left, and then 1, 2, 3, 4, 5 to the right. That's just the way I like to run it and draw it, my number lines. Okay. Anyways, so let's go ahead and plot negative 3. So negative 3 is to the left of 0, so 1, 2, 3. So that would be negative 3. And then negative 2 from 0 is 2 to the left, so negative 2. So which one of these is larger? Which one of these is closest to 0? That would be -2. So if I was to complete this comparison statement, -3 is less than or farther to the left, okay, than -2. So -3 is less than -2. Okay, on to number 4. So on number 4, I'm going to change this so that I have the same denominator. It makes it a little bit easier when comparing these numbers, and then I'll try to plot, and then I'll plot it on a number line. So if you look at 4 and you look at 2, okay, what is the least common denominator, or what is the smallest multiple they both have in common? That would be 4. So I'm going to convert both of these fractions so that they have the same denominator of 4. The first fraction already has a denominator of 4, so don't touch it, leave it alone. I'm going to convert my second fraction so it has a denominator of 4. Sorry. Okay, so make sure you write this down. So 2 times what is 4? That would be 2. And then 1 times 2 is what? 2. So now it might make it a little bit easier, okay, when we're doing this on a number line. So now let's go ahead and do this. So I'm going to draw my number line. And I'm going to put 0 right here. I don't have any positive numbers, so I don't have to worry about anything to the right of 0. So let's say 0, and I'm going to go 1 and 2. And since I have a denominator of 4, I'm going to go from 0 to -1, and 0 to -1 to -2. And I'm going to divide them up into 3 equal parts, or 4 equal parts, by drawing 3 lines. 1, 2, 3. 1, 2, 3. Each one of these lines is worth 1/4. So this would be -1/4, -2/4, -3/4. I already have -1 plotted there, so then we're going to go -1 and 1/4, -1 and 2/4, -1 and 3/4. All right, so let's go and plot our numbers. So we've got -3/4, which is right here. Go and plot that. So -3/4. And then -1 1/2 is -1 and 2/4, which is right here. So out of those 2 points that I just plotted on this number line, which one is closest to 0? That would be -3/4. So -3/4 is larger than, okay, -1 and 1/2, or -1 and 2/4. All right. So make sure, if you guys are getting confused with all of this, make sure you ask your teachers for help, okay? Hopefully they'll try and help you and show you, give you some more examples and explain it a little bit differently, maybe a little bit better than I'm explaining it here. So hopefully this makes sense to you. Okay, on to number 5. Okay, on problems like number 5, using decimals, I like to make sure that all of my decimals have the same amount of digits. So if you look at the first decimal, so 0.07, it has 3 digits, whereas 0.6 has 2 digits. So if I wanted to add digits to the second decimal, I would add a 0 at the end. So here we go. So 0.07, don't touch it, leave it alone. Then I got 0.60. Now, both of these decimals have the same amount of digits. And now at this point, think money. If one person's got 7 cents and one person's got 60 cents, come on, use your common sense. You guys all like money. Which one would be more, right? Is it 7 cents or is it 60 cents? So in this case, okay, 7 cents is less than, 60 cents. All right. So when it comes to decimals, if I can, I like to use money examples. Number lines can be used, but sometimes they take a little bit more time to explain. But think money, 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 money. All right. Here we go, on to number 6. Okay, the instructions for 6 through 9, it says order the rational numbers from least to greatest. Okay, so let's go start off with number 6. So for number 6, I zoomed in a little bit so I could draw myself a number line and explain this to you guys. So on number 6, I'm going to modify my number line just a touch, but draw yourself a number line. There's 0 in the middle. My largest number is 2.4, so positive 2.4. So I'm only going to draw myself like 3 hash marks, 1, 2, and 3. Same thing with to the left. I'm going to go 1, 2, and 3 spots to the left. So you got -1, -2, -3. and positive 1, positive 2, positive 3, okay, on my number line. So my first number is 2.4. So from 0, I go to the right at least 2 spots, but it's 2.4. So it's a little bit more than 2, but definitely less than 3. So you can estimate where you plot this. And I'm going to plot it in a different color. So let's say something like there. That might be where 2.4 is. Okay, so we're done with that one. Negative 1. So from 0, I'm going to go to the left 1 spot, and there's negative 1. Pretty straightforward, pretty simple. Now with 0.7, so from 0, I got 0.7. So 0.7 is not 1. It's actually less than 1. So just estimate where you think it would go. So like right there. Right? So pretty straightforward, pretty simple. And then you got negative 0.6. So from 0, I'm going to go to the left 0.6 spots. So 0.6 is a little more than a half. So let's say negative 0.06 would be like right there. So that would be negative 0.6. So if I'm ordering this from least to greatest, the number that is farthest from 0 is negative 1. After that, it's negative 0.6. Okay. After that, I have 0.7 as the smaller of what's left. And then my largest number is 2.4. Okay, so those are my numbers from least to greatest. Let's take a look at number 7. So on number 7, we've got some fractions here. So what I'm going to do with my fractions is I'm going to go ahead and rewrite them so they all have a common denominator, the fractions at least, right? So I've got negative 0, negative 1/2, negative 1, and negative 1/3. So I'm going to convert all of these fractions so they have the common denominator. So what is a common denominator of 2 and 3? That would be 6. You got it. So leave the 0 alone. So I'm going to change the second fraction so it has a denominator of 6. So 2 times what is 6? That's 3. And then 1 times 3 is 3. Negative 1, we can leave it alone. It's not a fraction. We don't have to mess with it. The last one, okay, negative 1/3. So we're going to convert that so it has a denominator of 6. So 3 times what is 6? That's 2. And then 1 times 2 is 2. Now all I have to do, okay, is compare, is go ahead and plot these on a number line. So I'm going to draw myself a number line, and I'm going to modify this one too, because we don't have any positive numbers. We have 0, so I'm going to put 0 all the way here to the right. We're dealing with negative numbers after that. Out of these negative numbers, which one is the largest? That would be negative 1. So I'm going to put negative 1 all the way over here. Why? Because the other two numbers that we have are fractions. And what's the denominator? The denominator is 6. So from 0 to negative 1, I'm going to divide this number line into 6 equal parts. So 1, 2, 3, 4, 5. So I got, in each one of these lines is equal to a sixth. So watch this. So I got 1/6, so negative 1/6, negative 2/6, negative 3/6, negative 4/6, negative 5/6, and negative 1. Let me rewrite that one just a touch. Dun dun dun. That one and that one. Sloppy sixes. Okay, and then negative 1 is the same thing as negative 6/6. Okay, so let's go and plot our points, shall we? In a different color, of course. So 0 is right there. Negative 3/6 is right here. Negative 1 is all the way to the left. Okay, and then negative 2/6 is right here. Okay, so if I were to plot these, or write these down from least to greatest, the smallest of all of these rational numbers would be negative 1. After that, it would be negative 1/2. After that, it would be negative 1/3. And the largest is 0. Okay, so that's how number lines can help you. Okay, let's take a look at number 8. Okay, so number 8, we've got negative 0.1, negative 0.8, negative 0.4, and negative 0.45. When we're talking just straight decimals like this, me personally, I like to think money, and I like to ensure that all of my decimals have the same number of digits. So out of these decimals, which one has the most amount of digits? That would be this one right here. It has 3 digits. So let's change all of our decimals so they have the same amount of digits. So negative 0.1, that would become negative 0.10. So I'm going to add the digit at the end. The next number is 0.80. Next one is negative 0.40. And the last one is negative 0.45. Now, when I'm comparing negative numbers like this, again, I like to think money. So forget about the negative signs for a second and let's think money. So this would be like negative 10, that would be 10 cents, 80 cents, 40 cents, and 45 cents. Now let's incorporate the negative sign back into the explanation. So out of these numbers, which one is the largest? That would be this one. It's the largest. So now that we're talking about negative numbers, that is the farthest, okay, from 0. So the farthest to the left of 0. So that's actually the smallest number. After that, okay, which is the largest number? That would be this one. So we're moving closer to 0. So negative 0.45. After that, I've got this number, negative 0.40. So we're inching towards 0 now. And the number that is closest to 0 is this one, negative 0.10. So hopefully that explanation makes a little bit of sense to you. If it doesn't, again, make sure you ask your teachers for a better explanation and maybe they can help you out. All right, moving on to number 9. So on number 9, we have negative 1 and 5/10, negative 1 and 9/10, negative 1 and 7/10, and negative 1 and 1/10. So we've got a mixture of decimals and fractions here. So I'm going to change all of these numbers, okay, into the same type of number. So I'm going to convert all of these into, let's say, decimals. Okay, so I'm going to change them all into decimals. So we've got negative 1 and 5/10. That's already a decimal, so leave it alone. The next number, negative 1 and 9/10, is the same thing as negative 1 and 9/10. Then we've got negative 1 and 7/10. And the last one, we've got negative 1 and 1/10. Now let's go ahead and put them in order. So when we're putting them in order from least to greatest, okay, think of the least number. That's the number that's farthest to the left of 0. So out of these numbers, which one is the largest? Is it 1.5, 1.9, 1.7, or 1.1? Let's forget about the negative signs for just a second. Out of those 4 numbers, 1.9 is the largest. So when you're talking negative numbers, negative 1.9 would be the farthest left of 0. After that, okay, we've got 1.5, 1.7, and 1.1. Out of those 3, what is the largest? That would be 1.7. So when you're talking negative numbers, okay, that would be the next number in line. After that, you've got negative 1.5 and negative 1.1. Which one is larger? That would be 1.5. So since we're talking negative, that number would come first. And leaving me with negative 1.1, which is the largest number out of all 4 of these because it is closest to 0. Negative numbers are kind of hard to understand and can be a little bit challenging, but the more you practice with it, the more you play with it, okay, the more you study, the more you understand, and the easier it becomes. You just have to grit your teeth and grind, guys. Grit your teeth and grind. You'll get it. You'll understand it at some point. Okay, moving on to number 10. Can you say hi, everybody? Oh, come on, Mrs. Burns. Play around. Play with me. Come on.
Hi, everybody.
Thanks, Mrs. Burns. Mrs. Burns just walked into their room. Haha. I got her into the video. All right, moving on. So for numbers 10 through 12, it says complete each statement with less than, greater than, or equal. Okay, so absolute value, remember, is a number's distance from 0. So on number 10, you've got the absolute value of negative 3.6. You want to compare that to the absolute value of 3.6. Well, the absolute value of negative 3.6 is, guess what? 3.6. And the absolute value of positive 3.6 is 3.6. So which number is less, which number is smaller? Neither one of these is smaller. Neither one of these is bigger. They're both equal to each other. Because you're talking absolute value, okay, which is the number's distance from 0. So on number 11, you've got the absolute value of negative 6.5 and the absolute value of 8. Let's go ahead and find their absolute values first. So the absolute value of negative 6.5 is 6.5. And the absolute value of 8 is 8. So in this situation, 6.5, the absolute value of negative 6.5 is going to be less than the absolute value of 8, because 6.5 is less than 8. Now, oh my gosh, trickery on number 12. So on number 12, we're going to find the opposite. Okay, so the negative sign on the outside of the absolute value sign, the way you read that is the opposite of the absolute value of 2. So the opposite of the absolute value of positive 2 is negative 2. And the opposite of the absolute value of negative 3 is negative 3. So when you're comparing these two numbers together, negative 2 and negative 3, which one is farthest away from 0? That would be negative 3. So negative 2 is closer to 0. So negative 2 is greater than negative 3. So the opposite of the absolute value of 2 is greater than the opposite of the absolute value of negative 3. Oh my gosh, Mr. Burns, this is so confusing. You're right. It is a little bit hard to understand. I get it. I understand that. Been doing this for a few days, so I do understand this can be a little bit challenging. But grit and grind, guys. Grit your teeth and grind. Study, study, study. And I guarantee you that at some point in your life, this will be easy to understand. I promise you. Okay, if you guys need any help, make sure you ask your teacher. Okay, beg them for help. Bother them until they help you. And if they don't, come and find me and I'll be more than happy to confuse you. All right, that's all I got. Mr. Burns, out.